Welcome to the Buckyball simulation. This simulation allows you to investigate and observe the physical properties of a spherical fullerene molecule, also known as a buckyball. In your laboratory, you will use various instruments and substances to put the chemical and physical properties of a fullerene to the test. First, click on the magnifying glass to view the molecular structure of a buckyball. Use the arrow buttons to spin the buckyball to view all sides of the molecule. Exit out and click and drag the fullerene to the empty glass beaker in the middle of the screen. While the fullerene is in the beaker, you can either turn on the optical absorption spectrum device or the cooling and conductivity device to analyze the substance. Once you make your selection, click on the device's display screen to view the data graph in greater detail. If no data pops up, then the device did not detect any of those particular properties in the substance. Test the other substances on the shelves by clicking on one of them to place it in the glass beaker in the middle. You can also combine individual substances with fullerene to see if they produce new properties together. Continue to experiment with all the substances on the shelves. When viewing the graph displayed by a device, you can scroll through the previous data you received from the other tests by clicking on the arrows at the bottom. Afterwards, click, drag, and release the fullerene to the Mohs hardness pad. The substance will scratch back and forth on the pad to determine its hardness. Next, place a chunk of fullerene in the hydraulic press. Turn the machine on to compress the substance to a smaller volume. Click the off switch to release the fullerene. Then place it on the Mohs hardness pad to see how the fullerene behaves when compressed. If you would like to refresh anything on the screen at any point, click the reset button to revert everything back to the original settings. Also, you can turn off the assisted pop-up boxes by changing the help switch to the off position.